Hi math students, this is just a quick refresher video on factorising quadratic expressions. So we're going to look at whether we can, from a giving quadratic expression, can we possibly take a common factor out? Is there a pattern we can use to factorise? So is it a perfect square? Can I use difference of two squares pattern? Or is it like a splitzees type scenario where I need to use the sum and product method to try and factorize the quadratic. Okay, so we're going to work through a fair few problems here, and we should work all the way down through these problems, finishing off with a bit of a complicated algebraic fraction problem. Alright, so starting off, we start really simply and look for a highest common factor in this part A problem. So if we look at each term, do that methodical approach where you're looking at both terms in this particular expression and thinking about what's the highest common number I could remove out there. What's the highest common number of x's? What's the highest number of common y's? And hopefully you come up with a highest common factor of 8x y to the power of 4. And then you're simply dividing that out. So remember to pop that 8xy in front. Sorry, 8xy to the 4 in front, and then think about what you're left over with after it divides into both terms. So the first one, I'm going to be left with x squared. The second one, I'm going to be left with 2y squared. And in a second video, we're going to look at how that can be further factorized as an extension to x plus square root 2y, x minus square root 2y, incorporating the difference of two squares pattern. Okay, in part B, we're looking at a difference of two squares factorization. This just relies on you being able to recognize that this particular expression is in the form of a difference of two squares. So essentially just looking at the terms, there's two of them. Can one be made up of a square number? And so combination of a square number and a square letter. And if I think about that carefully, I've got 2x squared minus 3 squared. Okay, so the A is representing my 2x, the B is represented by the 3. So I know that that can factorize nicely into the fact that I'm going to have 2x plus 3, 2x take 3. And we're done with that one. Press pause and have a quick go at the second part there, and we'll check in shortly with how you went. Okay, hopefully you ended up with that result. I should have pointed out in my first example that just remember, it doesn't matter which way with the difference of two squares pattern you write the final brackets. So they mean the same thing. So if you had it the other way around, that's perfectly fine. All right, let's move on to C here. Hopefully you can recognize with a bit of practice that it's the positive version of your perfect squares pattern. And the best way to kind of approach it is to do like a little check. So if we check and go look, is the first and last number, are they square numbers? So here I would go look, this is definitely x squared. And at the end there, that's definitely 3 squared, so they're both square numbers. And the last bit that you just need to check there before you know you can apply the pattern is, does the middle bit, so does the 6x, is that taking 2 times x times 3, because remember that's representative of our a and b term. Okay, and we can clearly see that we do have a perfect square pattern here. So you can do the little check step if you need to, but not necessary, particularly if you're told it's a perfect square pattern. And you can go straight to the fact that this is going to be our x plus 3 all squared, because it's in that a plus b squared format. Okay, have a quick go at parts 2 and 3 yourself, and I'll check in a second. All right, so how did you go? Hopefully you did like your little either mental check or you wrote it down to check, and you saw that it definitely was a perfect square. So the first term was squared, the last term was a square number, and the middle term was made up of 2 times the first term times the last term. Okay, and then same with the negative version of perfect squares pattern there being applied to part 3. That check that you can see that it's x squared minus 2 times x times 4 plus 4 squared to check in that it's a perfect square before you apply the pattern. All right, have a go at D. It is a perfect square. It's just not got the simple parts of the perfect square like we saw with the first 3 that we've done. All right, so with this one, you should be able to see that 4x squared is a square number. It is simply 2x all squared. When I check the last one, that's easily spotted as 7 squared. And then in the middle, do I have 2 times 2x times 7? Does that give me negative 28x? Well, yep, it definitely does. So then I know that I can go straight to the perfect squares factorisation to get 2x plus 7 all squared as my result for that. Okay, the next example there, E, is just kind of like a lead-up type of problem getting into that splitzees factorisation method. And what we're doing here is we're kind of splitting it in the middle here and going, look, the left-hand term there, does it have a common factor to the right-hand term there? And hopefully you can see that it's got a highest common factor that's a bracketed factor of x plus 5. So similar to that basic factorisation technique where I pop the bracketed factor out the front, and then because I'm dividing both those terms by my bracketed factor to move it out the front, you consider, all right, once I've taken that out, what am I left with in brackets? Well, if I've removed the x plus 5 from that term, I'm left with x. And then if I remove the x plus 5 from the second half, I'm left with minus 3. So then that simply becomes x plus 5, x minus 3 as my fully factorized expression. Have a go at part 2 there, and we'll check in. Alrighty, how'd you go? Hopefully, after you spotted the bracketed factor of 5 minus y and decided that's what you're going to divide out the front there, okay, so you're going to divide both those terms by 5 minus y, that bracketed factor. So remember that pops out the front, and then what I'm left with after I've divided those terms out is y on the left-hand term, and I'm left with negative 4x as part of the right-hand term. So I leave that remainder in my brackets down the bottom here. Okay, the questions in F are like the next step in looking for a bracketed factor. So here it's not been partially factorized already like we saw in E. Here we actually have to apply a bit of splitzees thinking and go look, if I was to look at the 2 left-hand terms there and then the 2 right-hand terms there, can you see a highest common factor to the left-hand side. So if I look at that, I can see that x is the highest common factor to both of those. And then when I look at the right-hand side, can I recognize a highest common factor to the right-hand side two terms there? So we're kind of incorporating this splitzees technique. Okay, and can I split it off and see if groups of terms have common factors there? So the right-hand side there, I can see it's got a common factor of -4. So what you do then is you factorize each of those halves. So here I'm removing out that factor of x, and what I'm left with, x squared divided by x is x, 2x divided by x is 2. Okay, and then dealing with the right-hand side there, -4x divided by 4. Okay, the -4 goes out the front, and I'm left with 1. And then -4 into -8 gives me positive. So then moving over to the right-hand side there, if I look at the highest common factor, that comes out the front, -4, and then what am I left with? -4 into -4x gives me just x, and -8 divided by -4 is +2. What a coincidence. If I look at what I'm left with now, I have a highest common factor to both those terms of the bracketed factor, x plus 2. So then repeating the process of what I did in part E there, I put that bracketed factor out the front, and what I'm left with, after I divide both this left-hand side and this right-hand side by x plus 2, what am I left with? Well, I've got x minus 4 left over. So I'll leave that in the remainder part. So the remainder part is always that right-hand bracket. See if you can have a go at part 2 there. All right, checking in. Hopefully you saw after you split it down the middle there, I can see that the left-hand side terms there, they've got a highest common factor of 4x. And then the right-hand side terms there, they have a highest common factor of 3. So if I then factorize both those halves, so the 4x comes out the front and the 3 comes out for the right-hand side there, we should recognize immediately we're on the right track because we can see they both have a bracketed factor of x plus 3. Then if that highest common factor gets brought out the front, I'm left with x plus 3, 4x plus 3. And we've fully factorized that one. Okay, this last lot of quadratics is just an extra step to what we've been doing so far. And we need to aim to split this middle term here into 2 parts, so then we can factorize each half, find a common bracketed factor, and end up with our fully factorized quadratics. Okay, so I call this the splitzees factorization method. And what you're doing is you take the coefficient of the first part of the expression next to the x squared, and you multiply it by the constant term at the end there. Okay, and whatever result you have, you then need to think about, okay, what are 2 factors of 10 that then add to give this middle coefficient value? So if I think about it, my factors could be 2 and 5, 1 and 10, okay, and positive or negative versions of those, but let's just check and see if any of those factors of 10 add to positive 7. Straight away I can see that 2 plus 5 gives me positive 7, so I know that works. So what I've actually found is what 7x will split up into, which is going to be positive 2x and 5x. Okay, from here I go through the process I did before, factorize each half here. Okay, then take out my bracketed factor. After I've taken out my bracketed factor, then I can see that I now have a fully factorized